Hello everyone and welcome to your partner in education, Agile Rank Mate. Today, in this particular episode of Measure with Mensa, we'll be looking at questions related to the Mensa examination. We'll be looking at sample questions and how to solve them effectively. So let's start off with today's first question. Fill in the missing plus, minus, multiplication, division, and or factorial signs to make the equation below correct, performing all calculations strictly in the order they appear on the page. 21 blank, 11 blank, 18 blank, 5 blank, 15 blank, 21 blank, 4 gives you 59. We need to find out what signs should be put in these blanks in order to get 59 as the answer. If you would have looked at it, the least values would be 5 times 4, 20. 5 times 15 would give you 75. 21 times 4 would give you 84. So multiplication wouldn't be present here. So let's start with addition. Let's add all the terms. 21, 11, 18, 5, 15, 21, 4. So 1 plus 1 is 2, plus 8 is 10, plus 5 is 15, 20, 21, 25. And then 2 plus 2 is 4, 5, 6, 7, 9. So if you were to add all of this, it would end up to be 95 and not 59. Now let's take a scenario. So basically it's just about trial and error here. Let's take a scenario where we remove 18 from the calculations. Let's start with 21 because 21 is the highest number. So let's put it this way: 21, 11, 18, 5, 15, 4. So that's 2, 10, 15, 19, 23, 4, 5, 6, 7. Now let's do 73 minus 21. That would be 2. Now obviously that would not be equal to 59 because the ones digit here is 2. 7 minus 2 is 5. So that's 52. Let's try with the next highest digit, which in this case is 18. So let's do it like this: 95 minus 18. So we remove the plus 18 from here. So 15 minus 8 gives you 7. I believe, yes. 8 minus 1 gives you 7. So 77. So that would be adding all of the terms given except 18. Now we'll subtract 18 from this. So 17 minus 8 is 9. This would be 6. 6 minus 1 would be 5. So the correct order of arithmetic operators here would be 21 plus 11 minus 18 plus 5 plus 15 plus 21 plus 4. And doing that, we will get 59 as the sum. So therefore, the final answer would be 59. So basically, the idea is plus minus plus, plus minus plus, plus plus plus. So this is the order of arithmetic operators that we should be using. Let's look at another question. James likes Iris, but not peony. Nicole likes Rose, but not Asta. Heather likes sunflower, but not lily. Which of the following does Stephen like? And you have 4 options given: hydrangea, carnation, tulip, lilac. Now, at the surface, there isn't any correlation between what the others like and what Stephen likes. So it just gives you 3 statements that shows that each person likes a flower but do not like a second flower, and none of these flowers are connected with each other. However, if you look at the names, it says James likes irises, Nicole likes roses, Heather likes sunflowers. And also note, the flowers are not referred to in their plural forms. They're all using singular forms. So that's something that's pretty important. Why is that? If you look at it, James, the name James ends with an S, and the flower Iris ends with an S. Similarly, Nicole ends with an E, Rose ends with an E as well. Heather ends with R, sunflower ends with R as well. So basically, each person likes the flower that has the same final letter as their name. So basically, the flower that Stephen would like would have an N at the end of the word. If you look at option A, it's hydrangea, that ends with an A, incorrect. C, tulip, is incorrect as well because it ends with a P. Lilac ends with a C, so that's incorrect. The right option is option B, carnation. So using the logic that James likes Iris because both ends in S, Nicole likes Rose because both ends in E, Heather likes sunflower because both end in R, then Stephen, whose name ends with an N, would be, by this logic, attracted to carnations because carnation ends with an N as well. So Stephen, carnation. James, Iris. Nicole, Rose. Heather, sunflower. Now let's look at the next question. What number should replace the question mark in the figure? So we have 4 figures. Each figure has an outer square that is oriented the right side up, and it has a smaller square inside it that is rotated at 45 degrees. So that basically the outer square stands on a side while the inner square stands on a vertex, and the vertex of the second square is on the bottom side of the first square. Now, inside the tilted square, you have a number, 21. And on top of the inner square's sides, facing outward, you would have 4 numbers. For instance, 8, 2, 8, and 3. Similarly, for the second figure, you have 14, 4, 4, 1, and 5, respectively. For the third figure, it's 16, 5, 4, 1, and 6. In the last figure, the number at the center is replaced with a question mark, and the outer numbers are given as 3, 7, 6, and 2. So, how do we find what number to replace the question mark? Well, let's look at the first figure, 21, and the outer numbers are 8, 2, 8, and 3. So basically, the first thing you would think of, or what you should be thinking of, is finding the sum of the outer numbers. So 8 plus 2 plus 8 plus 3. 8 plus 2 gives you 10. 8 plus 3 gives you 11. 10 plus 11 gives you 21. So basically, the sum of the outer numbers gives you 21. Let's test that theory. For the second figure, you have 4 plus 4 plus 1 plus 5. 4 plus 4 is 8. 1 plus 5 is 6. 8 plus 6 gives you 14. And as you can see, the number at the center is, in fact, 14. Let's also check it for the third figure in order to establish that this is indeed the relation that we should be looking at. So we have 5 plus 4 plus 1 plus 6. So 5 plus 4 gives you 9. 1 plus 6 gives you 7. 9 plus 7 gives you 16. So therefore, the relation where the sum of the outer numbers gives you the inner number is in fact correct. So for the fourth figure, all we have to do is find the sum of 3, 7, 6, and 2. 3 plus 7 gives you 10. 6 plus 2 gives you 8. And 10 plus 8 gives you 18. So therefore, the number that should be replacing the question mark is 18. Because basically it is the sum of the 4 numbers that are outside the tilted square. So therefore 18 turns out to be the right answer. Now let's look at the final question for this episode. Decipher the names of several celebrities using the cell phone dial as a guide. So we have three codes given here. These represent the names of some celebrities, and the code, the guide that is given to you is 2 stands for A, B, or C, 3 stands for D, E, or F, 4 stands for G, H, or I, 5 stands for J, K, or L, 6 stands for M, N, and O, 7 stands for P, Q, R, and S, 8 stands for T, U, V, 9 stands for W, X, Y, Z. So it's kind of similar to the cell phones that people used before smartphones entered the fray. So basically it's the same code. So based on the number and the permutation of letters that's possible, you need to decipher the name of a celebrity based on the code that's given. Let's start with code A. So the first number is 3. Then you have 2, then you have 6, then 4, 3, 5, 7, 2, 3, 2, 5, 4, 3, 3, 3. So, how do we solve this? Well, it's a good idea to write the possible letters that the number can represent right below the number. So since 3 is D, E, and F, we will write D, E, and F below it. 2 stands for, of course, A, B, or C, so we'll write A, B, and C under it. Going by the same methodology, 6 would stand for M, N, O, 4 would stand for G, H, I. So then 3 would stand for, again, D, E, F. 5 would stand for J, K, L. 7 would stand for P, Q, R, S. 2 would stand for A, B, C. 3 would stand for D, E, F. 2 would stand for A, B, C. 5 would stand for J, K, L. It's not J, it's L, so we would just have to erase that. 4 would stand for G, H, I. 3 would stand for D, E, F, of course. We'll just repeat that thrice because there are 3 3s at the end. Okay, so let's look at combinations that can work. So the name could start with D, E, or F. Then you have A, B, and C. So there's D, A, E, A, F, A. So D, A, and all of these are possible. D, B wouldn't work. E, B might. F, B also does not work. Then if you go to M, N, O, you would have D, A, M. However, that wouldn't lead to a known celebrity's name. D, A, N, of course, would lead to one because we have names such as Danny, Danielle, etc. So let's focus on Danielle because the next number 4 has G, H, I, which has I. So D, A, N, I. Then you have 3, which has E in it. So D, A, N, I, E. And 5, that gives you L. So basically, the first name of our celebrity could be Daniel. So that's up here. So of course, Daniel that we know of in the fields of entertainment, sports, fine arts, etc. When it comes to movies, you can remember Daniel Day-Lewis, Daniel Radcliffe, etc. If you look at 7, 7 has R, 2 has A, 3 has D. So that gives you R-A-D. So that would mean that it's possible that this number would spell out Daniel Radcliffe. Of course, also the numbers after the first name would also give you a clue as to how long the surname would be. So you have R, you have A, you have D, and 2 gives you C, 5 gives you L, 4 gives you I, the first 2 3s gives you F, and the last 3 would give you E. So of course, the name of the first celebrity showcased by the code marked as A is Daniel Radcliffe of the Harry Potter series. Now, let's go to B, and we'll use the same methodology in order to get our answer. So 5 stands for J, K, L. 8 stands for T, U, V. 7 stands for P, Q, R, S. 8 stands for T, U, V again. 4 stands for G, H, I. 6 stands for M, N, O. 8 stands for T, U, V. 4 stands for G, H, I. 6 stands for, again, M, N, O. 2 stands for A, B, C. 3 stands for D, E, F. Now again, it's important to note that using the code and writing it under each letter is just the methodology that we use to facilitate the next step of the process, which is elimination and identifying the celebrity name that is hidden here. So JKL, A, B, C for 2, JKL again for 5, and D, E, F for the final digit, that is 3. So if we look at 5 and 8 together, JT, KT, LT wouldn't work. JV, KV, and LV wouldn't work. So whatever the name is has to have 8 must be fixed with U because that is the vowel, so it's more likely to be included. So JU, KU, or LU. So JUP doesn't recall any names. JUQ wouldn't. JUR, again, no famous names come into mind. JUS, of course, would be a possibility. So KUR, again, is a similar possibility. So let's stick with JUS. And then you have TUE, so JUSU, JUSV wouldn't work, but JUST, yeah, that would work. And then after T, in the code for 4, T and I would make the most sense, so JUSTI. And in 6, if you have JUST and I, then for 6, the letter that it represents has to be N. So we're dealing with a celebrity whose first name is Justin. All right, so now that we know that our celebrity's first name is Justin, let's look at the rest of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is someone who has 10 letters in his surname. So so we need someone famous named Justin who has a long surname. First name that comes to mind would be Timberlake. So let's test the theory. 8 would stand in for T. 4 would stand in for I. 6 codes for M. 2 codes for B. And 3 codes for E. 7 codes for R. 5 here codes for L. 2 codes for A. 5 codes for K in the penultimate place. And the final digit 3 would code for E. So Justin Timberlake turns out to be the celebrity name coded here. So we have the singer Justin Timberlake as the name of the celebrity that was coded in B. Now let's look at C, which is the final code for this particular question. We have 64, 24, 23, 55, 67, 326. So 6 would stand for M, N, O. 4 would stand for G, H, I. 2 would stand for A, B, C. 4 would stand for G, H, I. 2 would stand for A, B, C. 3 would stand for D, E, F. 5 would stand for J, K, L. Again. 6 would stand for M, N, O. 7 would stand for P, Q, R, S. 3 would stand for D, E, F. 2 would stand for A, B, C. And the final 6 would stand for M, N, and O. So we have 6, 4. These are the first 2 digits. So MG, NG, OG wouldn't work. MH, NH, OH might work. Then you have MI, NI, or OI. So MI, NI, OH, these are the potential starting points. MIA is possible. MIB is kind of unlikely. MIC is also pretty much something that's possible because it leads to a common name. So NIA, NIB may not be. NIC is also highly unlikely. OHA possible. OHB and OHC are not possible. So let's go with MIC for now. MICG and MICI are very rare. MICH, yes, is possible. And MICH, then you have the next one, we use the vowel, which is A, so MICHA. And of course, that would lead us to the common name Michael. So you have 6424235 coding for Michael. Then you have 567326. So we need to find a certain celebrity named Michael whose surname has 6 letters. Of course, one of the popular names that we could think of would be Michael Jordan. So if you look at the next digit after Michael, then it's 5. So J does code for that. 6 gives us O, so JO. 7 gives us R, so JOR. 3 gives us D, so JORD. 2 gives us A, and 6 gives us N. So therefore, this is definitely Michael Jordan. So C codes for Michael Jordan, B codes for Justin Timberlake, A codes for Daniel Radcliffe. Now that concludes this particular episode of Measure with Mensa. We hope you found this episode interesting and informative. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. If you want to learn more about Mensa or any of the other examinations that we are looking into, then please don't forget to hit the bell icon present below the video. So until the next episode, take care, stay alert, bye-bye for now.